So the first thing you're going to do, the first step of that procedure would be to clear off this flange. Normally there would be some material on it. The way I do it is I would just kind of squeeze the sponge into it and then just wipe it off all the way around. The reason for that is there's a rubber seal right here. If this doesn't have a good seal, it will leak, and that would invalidate the test. All right, so we get that seal wet. Set it on there, give it just a little bit of a twist, make sure it's seated properly, and then you're going to clamp opposite sides at the same time. If you don't clamp them at the same time, you're going to tell this one's going to be fun. Out of adjustment. If you don't clamp them at the same time, it'll pull it off center, and you'll most likely end up with the leak. So you clamp opposite sides at the same time. All right. So these are your petcocks. This is your pump. This is your main valve. This is your bleeder. And this obviously is your dial gauge, okay? So the way that this works is that this is a long needle that runs into a hole in the bottom of this cover. It's spring loaded. So once you push this down, it lifts the needle out of the hole and will let the air that's in this chamber let it be introduced into your sample. Once that pressure hits your sample, it's going to force all the air that's in the material back up into the cylinder, your main chamber, and into your dial. So when you're doing your stabilization and you're reading with this, you want to make sure you do all that while this is depressed, all right? Because that's the only time you're actually tied into your sample, right? So you don't want to push it, let it go, and then stabilize. You don't want to do any of that because you're just dealing with this and not really dealing with your sample at that point. So all that is done while it's being held down. So kind of went fast forward, so let's go back. We just clamped our cover, our petcocks are open. So now what we want to do is we want to fill this with the volume of water until it's there's no air bubbles left in there. This material is pretty granular, so it would probably take a lot of water to do that. Normally, it's like 3 of these bulb syringes until you see water starting to come out the other side. We'll give it a shot and see. Probably use this whole bucket. If it takes too much, we'll just pretend it's doing it. I'll show you the steps. You get to like 6 of these and we don't see it yet. I'm sure it's all just going in there. But at least this will give you the idea how it's supposed to go. So when you pull it out, you just keep it depressed, suck up the water back into it. All right, so now we're gonna say that we're starting to squeeze and water's coming out. So there'll be water, but you'll see air bubbles as well. So there's a little motion that you have to do while you're squeezing the water in, and that would be to tilt it towards your bulb syringe. And what that's gonna do is it's gonna allow any air bubbles to travel upward towards this hole, right? So as you're squeezing it, you're seeing the air bubbles are starting to disappear, and now it's just pretty much just the water coming out. So as you see the water come out, you continue squeezing as you set it back down, continue squeezing as you pull it out, and by doing that motion, you'll end up with water right at the top of both, and that's what you want. All right, so the motion is squeeze, tilt up, you can even shake it a little bit if you want, continue squeezing as you set it down, continue squeezing as you pull it out. You'll have water right to the top. Now you're gonna leave these open. The reason we leave these open is because as you're pumping this up with air, if for some reason the main valve wasn't seated properly, you would see air bubbles come out right here. So what it does by leaving it open is it really helps you validate the test, right? If these were closed and it was leaking, you wouldn't know. So you wouldn't get a good test result, you wouldn't be aware of it. So that's the main reason to leave them open. And this is the biggest thing I see people fail on in this, because it kind of makes sense after you finish filling something to close it, but don't, okay? So you filled it up, you got water to the top. Now we're gonna pump it up to our initial pressure. So on our dial face, you'll see a little 3%. There is usually always a number on your dial face. That's written on there during the calibration of the equipment, which is annually, or anytime there's a question of the equipment's accuracy. So here's the calibration date. It says 3%. So the 3% isn't this big 3 up here. It's the 3% beyond the 0. The reason we have that range is because as the equipment wears, our 0 would never be true 0, just because of the wear of the equipment. So by having that range, it allows for us to have a way to make a zero actual an actual zero starting point. So on this one it's 3%. We'll start pumping it up. So we're going past the 0 to the little 3%. I'm going to purposely go past the 3. Oops, I went too far. You would use your bleeder valve, if I can open it, to release some of the pressure. You see it start to drop down. All right, so now I'm just right before the 3, so now you can do little short stabs, right? You don't have to do those big full strokes. All right, and tapping the dial is also part of the steps. So make sure that you pumped it up, you stabilized it. We're right on the 3. At that point, you can close your petcocks, get your mallet in hand, and now we're going to release the air pressure that we just put in here and introduce it into our sample. While you do that, you want to give it a couple of sharp taps with the mallet. Then you're going to stabilize the gauge. Once it's stabilized, then you can take your reading, or you can read it while you're holding it down. Because of all the air we had in there, I'm going to pump it back up to where it normally would be. We kind of have a better idea of what it would look like. Okay, we'll say we did all that and it landed right here. So the next thing you want to take note of is that you read the dial in the right direction. It runs backwards. So we're not at 2.1, we're at 1.9, okay? Make sure you're reading it in the right direction. Once you say, okay, I have 1.9%, they're gonna give you an aggregate correction factor. It's gonna be a small number. Whatever number they give you, make sure you subtract it from the number in your dial, all right? So they say, okay, I have a 1.9. Say, okay, you have an aggregate correction factor of 0.3. What is your final air content? You would tell them 1.6, all right? You're just gonna subtract whatever they tell you. Once you tell them that number, then you finish that portion. If this assembly isn't part of the test, but you'll cup your hand over one of the sides, that'll release the air that we put in here. You'll remove your cover. And then once you're clear of your sample, we still have air in here, we'll release that. And then as general maintenance, you would just hit that one more time, pump it up all the way, and then hit that main valve one more time. That's just a maintenance thing. These are aluminum. If any moisture stays in these for any length of time, there's like this weird jelly that forms, and then the gauge won't work for you or the next guy that wants to use it. So it might seem trivial, but if you're somewhere far and you have this and it doesn't work, you're gonna be mad. All right, so that's pretty much it for that one. Is there any questions on the equipment or the procedure?